You are welcome back. I want to examine material mix and yield variances with wastages or normal loss. This is the part 3. In this part 3, I tend to solve questions from the past ACCA examination questions. The question is obtained from Kaplan ACCA Practice and Revision Kit Performance Management. If this is your first time of coming across my channel, or if you have not subscribed previously, please don't forget to click on the red subscribe button and turn on the notification bell icon so that you will be notified each time I drop a new video. If you are a returning subscriber, I say thank you and God bless you. So the formula I gave you in part 1 and part 2 will still be used. I've told you that material mix variance. I said it is revised standard quantity minus actual quantity multiplied by the standard price. I've told you that revised standard quantity, I said it is standard quantity multiplied by the actual mix. Actual mix. And I've told you that actual mix is the total actual input for the period. The total actual input for the period will give us the actual mix. And I've also made you to understand that in the computation of material mix, so you don't need the material wastages. In the computation of the material mix variance, no material wastages is affected. That is, material wastages is not affected by the mix variance. So, meaning that information about the wastages of material should be ignored. 2. Material yield variance. Material yield variance. The formula I gave you, I said it is the standard quantity based on actual production minus the revised standard quantity multiplied by the standard price. So these are the formula I gave you, and I made you to understand, or I let you to understand that you will need to take into account the materials wastages when computing the yield variance. You are going to take into account the materials wastages when computing the material yield variance, but you are not going to take into account the material wastages when computing the mix variance. The wastages or normal loss will only be considered in the computation of material yield variance. Now let's look at the question before us. So, Kappa Co produces omega, an animal feed made by mixing and heating 3 ingredients: alpha, beta, and gamma. The company uses a standard costing system to monitor its costs. The standard material cost for 100 kg of omega is as follows. You have input kg, cost per kg, and cost per 100 kg of omega. You have the alpha, beta, and gamma. 40 kg, that is the standard quantity, 60 and 20 respectively, and that is sum up to give us 120. But now this is the standard input, and you were told that it was based on 100. That is, the standard material cost for 100 kg is what you are given here. If it is for 100 kg, that means this is supposed to be 100. That means based on your estimate now, 120 will be used to produce 100. Therefore, 20 have been lost. That means there is material wastages of 20 kg. And you are given information about the standard cost per kg and the standard cost for 1 unit of the material or 1 unit of the product. Notes: the mixing and heating process is subject to a standard evaporation loss. It's subject to standard evaporation loss. That means there will be loss of materials in the process of heating and mixing the material. Alpha, beta, and gamma are agricultural products, and their quality and price varies significantly from year to year. Standard prices are set at the average market price over the last 5 years. Capaco has a purchasing manager who is responsible for pricing and supplier contracts. The standard mix is set by the finance department. The last time this was done was at the product launch, which was 5 years ago. It has not changed since. Last month, 4,600 kg of omega was produced using the following inputs. This is the output. 4,600 was produced. This is the output. Input, you are given input kg, cost per kg, and total cost. For alpha, 2,200, $1.8 per kg, and 3,960. Then beta, 2,500, $6 per kg, and 15,000. Gamma, 920 at $1 per kg, then we have 920. The total input is 5,620 and the cost is 19,880. At the end of each month, manager receives a standard cost operating statement from Capaco Performance Manager. The statement contains material price and usage variances, labor rate and efficiency variances, and overhead expenditure and efficiency variances for the previous month. No commentary on the variances is given, and the production manager receives no other feedback on the efficiency of the omega process required. Calculate the following variances. 1. The material usage variance for each ingredients and total. 2. The total material mix variance. The total material mix variance. 3. The total material yield variance. Please, I want you to note, in the computation of mix and yield variance, you are going to allow for material wastages. That is, material wastages will be put into computation in the computation of material usage variance and material yield variance. You will consider the material wastages in the computation of material usage variance and material yield variance. But you don't consider the wastages in the computation of material mix variance. So, and I've told you that if you have watched my previous lectures on material variances, I've told you that material usage variance, materials usage variance, I said it is standard quantity based on actual production minus actual quantity multiplied by the standard price, where SQ stands for standard quantity, BOAP means based on actual production. I've told you that you should always flex your standard quantity by multiplying the standard quantity as given in the question by the actual production. And this is the actual quantity given, and this will be given in the question. The standard price information will equally be given. So we want to compute the standard quantity of production. standard quantity of production. That is your standard quantity based on actual output. So you use three materials. You have alpha, beta, and gamma. I've told you that in the computation of material usage and material yield, that you are going to consider the material wastages. The standard quantity of material alpha is 40 and 60 for beta, then 20 for gamma. Total 120. Alpha 40, beta 60, gamma 20, total 120. I said you are going to allow for material wastages, normal loss. The normal loss as given, you were told that the standard material cost for 100 kg of omega is as follows, and you are having 120, and you were told it's for 100. So if the standard input is 120 and it's ought to be 100, that means 20 kg have been lost. So the normal loss will be 20 kg. 20 kg. When you subtract 20 kg, then you have 100. Don't forget, I've told you that the computation of material usage and material yield, you are going to allow for the normal loss. Now, I've told you that your standard quantity of production, that is, you have to flex it by multiplying it by the actual output. You have to multiply by the actual output. Then you read the question to identify the actual output for the period. We were told last month 4,600 kgs of omega was produced using the following inputs. 4,600 kg was produced. That means the 4,600 is the actual production, that is actual output. So that is actual output. Therefore, our standard quantity will be 40 for alpha over 100 after allowing for normal loss times 4,600 as given. 4,600 kg. Then for beta, that will be 60 over 100 times 4,600 kgs. For gamma will be 20 over 100 times 4,600 kgs after allowing for the normal loss. So 40 times 4,600 divided by 100, then we have 1,840 kg for alpha. For beta, 60 over 100 times 4,600, then we have 2,760 kg. For gamma, we have 20 over 100 times 4,600 kg. Then you have 920 kg. That is the standard quantity. This is workings. Let me have working one. For the purpose of yield variance or variances, let me also compute for the purpose of means and yield variances. Let me also compute the revised standard quantity. Revised standard quantity. Revised standard quantity. You have for alpha, you have for beta, we equally have for gamma. gamma. The standard quantity still remain the same, 40, 60 and 20 as given in the question. 40, 60 and 20. So the total is 120. To compute your revised standard quantity, you don't need to consider the material wastages. You don't need to consider the material wastages. I've told you that this revised standard quantity, that is, I've told you that the revised standard quantity is standard quantity multiplied by actual mix. And I've told you that our actual mixture will be the total actual input of materials. Now, if you go through the question, what is the total actual input? Total actual input, which is actual mix. That is 2,200 plus 2,500 plus 920, and the total is given to be 5,620 kg. That is the actual mix. So our actual mix is 5,620 kg. 5,620 kg. You are going to apportion this actual mix with our standard quantity. You don't need to allow for material wastages. So this will be 40 over 120 times 5,620. This will be 60 over 120 times 5,620. While this will be 20 over 120 times 5,620 kg. And that will give us 5,620 times 40 divided by 120. This will be 1,873. 1,873 kg. For beta, so that will give us 60 over 120 times this will give us 2,810 kg. For gamma, so you have 20 over 120 times 5,620, and that will give us we have 937 kgs. We have determined our revised standard quantity. We therefore want to compute the material usage variance as required. Materials usage variance. I've told you it is standard quantity based on actual output minus standard quantity based on actual output minus actual quantity multiplied by the standard price. We have three materials. We have alpha, we have beta, and gamma. The standard quantity have been computed. The standard quantity of production, and we have 1,840, 2,760, and 920. So we have 1,840, 2,760, and 920. Minus actual quantity. Actual quantity as given in the question We have for alpha, that is our actual input, 2,200, 2,500 and 920. Actual quantity, so we have 2,200 kg, 2,500 kg and 920 kg. That is our actual quantity multiplied by the standard price. Our standard price, you go to the information about standard, which is the standard cost per kg. We have $2, $5 and $1. So our standard price, $2, $5 and $1 per kg. $1,840 minus 2,200. The difference is 360 times 2. Then we have 720 adverse. $720 adverse. Then we have 2,760 minus 2,500 multiplied by $5. Then we have 1,300. 1,300 favorable. Then we also have 920 minus 920. $920 kg minus 920 kg. That will give us 0 kg. 0 kg multiplied by $1. That will be $0. So when you sum up, this is favorable 13, adverse 720. So when you subtract the adverse from the favorable, then you have the difference of 580. It will still be favorable because favorable exceed adverse. 580 favorable. That is materials, usage, variance. We have computed our material, usage, variance. We therefore want to compute or calculate the material, mix and the yield variance. Material mix variance and the material yield variance. Material mix variance 2. You want to compute the total material mix variance. Total material mix variance. I've told you that the formula is the revised standard quantity minus actual quantity multiplied by the standard price. And we have 3 materials. We have alpha, we have beta, and gamma. The revised standard quantity have been calculated. Revised standard quantity. Revised standard quantity. For alpha, we have 1,873. That is our revised standard quantity. For beta, 2,810, and for gamma, 937. So now we substitute. For alpha, 1,873. For beta, 2,810. 810, and for gamma 937. Minus actual quantity. Actual quantity is given. For alpha, we have 2200, beta 2500, and gamma 920. So, minus actual quantity, alpha 2200, for beta 2500, and for gamma 920, multiplied by the standard price. The standard price is equally given in the question, where you have information about the standard. The standard material cost for 100 kg of omega is as follows. So we have for alpha, these are the cost per kg. This is the standard price per kg, and this is the standard cost per unit. So we have 2, 5, and 1. That is our standard price. 2, 5, and 1. So 1873 minus 2200, then multiply by 2, then we have 654 adverse. 654 adverse. Then 2810 minus 2500, then we have 310. 310 multiplied by $5, then we have 1550 favorable. Then 937 minus 920, then we have 17 times 1, that will still be $17, which is also a favorable variance. When you add up the favorable, 17 plus 1550, that will give us 1567, minus adverse of 654, minus 654 adverse, then you have 913 favorable. That is material means variance. That is the material means variance. Then, having computed the material means variance, the next thing is to calculate the yield variance, the material yield variance. That is the third one. Three. Material yield variance. I've told you that the yield variance, I said it is standard quantity based on actual production minus revised standard quantity multiplied by the standard price. We have alpha, we have beta, and we also have gamma. Alpha, beta, and gamma. Standard quantity based on actual production. The standard quantity of production for alpha 1840, for beta 2760, and gamma 920. That is the standard quantity based on actual production. So alpha 1840, beta 2760, gamma 920 minus revised standard quantity. we have equally determined that revised standard quantity for alpha 1073, beta 2010, and gamma 937. That is our revised standard quantity. So 1873, 2010, and 937. Then you multiply it by the standard price. Multiplied by the standard price, and our standard price still remain unchanged: 2, 5, and 1. 2, 5, and 1. 2, 5, and 1. So now have 1840 minus 1873 multiplied by 2. Then we have 66. 66 adverse, because this exceeds this. So it's an adverse variance. Then 2760 minus 2810 multiplied by 5. Then we have 250 adverse. 250 adverse. Then we also have 920 minus 937 multiplied by 1. Then that will still give us $17 adverse. $17 adverse. So you may sum them up. Then adverse, everything is adverse. So when you sum it up, 66 plus 250 plus 17. Then we have 333 adverse. That is material yield variance. 333 adverse. Now that we have determined the yield variance, now let us have the summary of the means and the yield variance to confirm if it will agree with the material usage variance. So we have means variance summary, means variance, and the yield variance. The yield variance is 333 adverse. 333 adverse. The means variance is 913 favorable. 913 favorable. So when you sum it up, you know adverse is negative while favorable is positive. So the difference will be 580 favorable. It is still favorable because favorable exceeds adverse. Therefore, the material usage variance is 580 favorable. Now, let's check our workings where we calculated the material usage variance and we got $580 favorable. Please, my next part or my next lecture on means and yield variances will be the solution to further examinations questions. Thanks.